All right, this is lesson 8.2, special right triangles. We have two triangles that we're going to talk about today. So there's some special properties for the 45, 45, 90 and the 30, 60, 90 triangles. So when we finish, we're going to be able to use some of those properties to make solving and finding information about it easier. Okay, so let's take a look at this triangle. So it doesn't have any information about the sides. I'm going to add that later. But what do we automatically know when we see that the base angles are equal? We know from this information right here it's an isosceles triangle. So what does that mean? So that means that the two legs are equal also. So let's go ahead and throw in a number. So if this leg is 3, and this leg is also 3 because it's an isosceles triangle, I want to find the length of the hypotenuse. So I can use the Pythagorean theorem. So I'm going to say 3 squared plus 3 squared is equal to c squared. So 9 plus 9 is equal to c squared. 18 is now equal to c squared. Okay, so let's simplify this because we need to take the square root of both sides. So 18 is going to give me 2 and 9, and 9's a perfect square, so then I've got a pair of 3's. So this length is equal to 3, and singles stay home, square root of 2. Pairs go out, singles stay home. Okay, let's do another one. Let's suppose that this one is the length of these legs are 5. So again, I'm going to use the good old Pythagorean theorem. So I've got 5 squared plus 5 squared is equal to c squared. 25 plus 25 is equal to c squared. Add those up, so 50 is equal to c squared. I'm going to take the square root. So let's see what I can do for 50. So 50 is 2 and 25. Oh, another perfect square. 5 and 5. Pairs go out. Singles stay home. So this one is 5 square root of 2. So let's take a look at these two that we've just worked. So this one was the sides were 3, and my hypotenuse was 3 square root of 2. So this one, my sides were 5, and my hypotenuse was 5 square root of 2. So what do you think that means? Is that just a happy coincidence? Of course not. There's no such thing as a coincidence. So now let's try to apply it. If we're told that the hypotenuse is 14 square root of 2, what are the length of the two sides? What's the length of this side and what's the length of this side? So this one is 14 and this one is 14. So, of course, there's a theorem to go with that. So this is theorem 8.5, the 45, 45, 90 triangle theorem. So in a 45, 45, 90 triangle, both legs are congruent because it's an isosceles triangle, and the length of the hypotenuse is the square root of 2 times the length of the leg, whichever leg I wanted, because they're the same. So now, let's take a look at problem 1. So the first thing I'm going to do is I'm going to look to see I've got a right triangle. My base angles are 45. I know things about the 45, 45, 90 triangles. This is my leg. What's the length of my leg? 9. So what does that mean the length of my hypotenuse is? 9 square root of 2. Will the Pythagorean theorem work? Absolutely. And so the other thing you could do is you could do the Pythagorean theorem. Okay, so now let's look at the next problem. So I see I have a right triangle. Oh, it's a 45, 45, 90. I know things about that. So the hypotenuse is equal to the length of the leg times the square root of 2. Now this looks scary. So if this freaks you out, I'm going to suggest that you get rid of this number. We're going to bring it back in a second. And what would you do if the number was just 2? Well, I know it would be the length of my leg, which is 2, and the square root of 2 would be the length of my hypotenuse. So if you can do it when it's a simple number, you can do it when it's a scary looking number. Okay, so now my number is 2 square root of 2. So the hypotenuse is equal to my number, whatever it happens to be. This time it just looks a little different. So I've got 2 square root of 2 times the square root of 2. Now what is the square root of 2 times the square root of 2? Well, that's just going to give me 2. So now I have 2 times 2. And so that is equal to 4. So my hypotenuse is just 4. Okay, now let's take a look at problem 2, finding the length of the leg. It's a multiple choice question. They want to know what the value of x is. I see that x is a leg. So the number that they've given me is my hypotenuse. I see I've got a 45, 45, 90. So what is the hypotenuse equal to? The hypotenuse is equal to, so it's 6, and that's the same thing as the square root of 2 times the length of my leg, which in this case is x. So I'm looking for x, so this works out perfect. So now I'm going to divide both sides by the square root of 2. So now I have 6 square root of 2 is equal to x. Now if you remember back from Algebra 1, you can't have a radical in the denominator. So what we're going to do is we're going to get that guy out. So we're going to multiply by 1, but our 1 is going to look different. Our 1 is going to be disguised as the square root of 2 over the square root of 2. Because anything over itself is just what? It's just 1. So now I have 6 square root of 2 over, what's square root of 2 times the square root of 2? That's going to give me 2. So now I simplify. What is 6 divided by 2? That's 3. So my final answer is 3 square root of 2. So my answer is B. Okay, let's take a look at problem 3. So we're going to find the distance. Let's see. Softball. A high school softball diamond is a square. What do we know about squares? All of their angles are right angles. Okay. The distance from base to base is 60. So the distance from home plate to first is 60 feet. First to second is 60. Second to third is 60. And third home is 60. So to the nearest foot, how far does a catcher, the catcher's back here at home plate, throw the ball from home plate to second base? So that's going to be this diagonal right here. So, what do you think I'm going to do? Well, what do we know about this diagonal? What did it make these two angles equal? The diagonal of a square or rhombus bisects the angle. So this would be 45 degrees. So I've got a 45, 45, 90. So this is going to be cake for me to solve. So what is the hypotenuse? Well, it's my leg, which is 60, times the square root of 2. So I know that the distance is equal to 60 times the square root of 2. So this would be the exact answer. And I don't know about you, but this doesn't mean a whole lot to me. So I'm going to get my handy dandy calculator and I'm going to multiply 60 times the square root of 2. So when I plug that in my calculator, I get this really long decimal. Let's see, 84.8528.137. Let's see. So they want to know to the nearest foot, how far does the catcher throw the ball? So the catcher throws the ball approximately 85 feet. Okay, so our second special right triangle is the 30, 60, 90 triangle. And it's named so because it's got a 30-degree angle, a 60-degree angle, and a 90-degree angle. So let's see, in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. So the shorter leg is S, the hypotenuse is 2 times that, and the length of the longer leg is the square root of 3 times the shorter leg. So at first this might be a little bit tricky to remember, but the more you do it, the easier it's going to be, and it'll save you a ton of work. So I would recommend spending a few minutes to learn this. So let's see what we can do with it. So let's say on this triangle, my short leg is 5. So if my short leg is 5, what is my hypotenuse? Well, my hypotenuse is 2 times the short leg, so 2 times 5 is 10, so my hypotenuse is 10. Now what is my long leg? My long leg is 5 square root of 3. Now let's try this one. Now what if they give you the hypotenuse? Well, what's a short leg? Well, this is 2 times the short leg. So what's half of 30? Well, that's 15. Oh, now I have the short leg. I can do my long leg. So my long leg is the value of the short leg times the square root of 3. Okay, and one more. So this is a right triangle. It is a 30, 60, 90 triangle. And let's say they give us the long leg, which is 10 square root of 3. What is the length of my short leg? My short leg is 10. What is the length of my hypotenuse? my hypotenuse is 20. Okay, so just be aware this can be a little bit confusing, so feel free to pause and back up for wherever you get confused, if you get confused. So this one we're going to, using the length of one side, what is the value of D in simplest radical form? So they give us this triangle, and I drew this one over here because it has the, our theorem information on it. So the short side, the hypotenuse is equal to 2 times the short side. The long leg is equal to the short side times the square root of 3. So that can come in handy. So I just have it there if you need it as a reference. So they give us the long leg. So what is the long leg equal to? Okay, so the long leg is equal to the short side times the square root of 3. So what is the short side? Well, in this triangle, it is D. So 5 is equal to D times the square root of 3. So I got that from right here, long leg and long leg. So we're just comparing these because 5 is equal to the short side times the square root of 3. So now we need to isolate our variable. So I'm going to divide both sides by the square root of 3. So this cancels out. So now I have 5 over the square root of 3 is equal to D. Now remember, we can't have a radical in our denominator, so we're going to multiply by that weird 1 again so that we can get rid of it. So we're going to multiply by the square root of 3 over the square root of 3. It looks weird, but square root of 3 divided by the square root of 3 is 1. We just kind of dressed it up a little bit. So now we have the square root of 3 times 5 all over 3 is equal to D. And this is our simplest radical form, so we are done. Okay, last problem. So now we're going to apply the 30, 60, 90 triangle theorem with jewelry making. An artisan makes pendants in the shape of equilateral triangles. What do we know about equilateral triangles? I know that every angle is 60. So I know that this is 60, and this large angle up here is 60 as well. So the height of each pendant is 18 millimeters. So it comes from the vertex and drops down. What else do I know? Well, that tells me that these two are congruent. Now, what is the length of all 3 sides? Well, all 3 sides are S. So what is the length of this one? It is 1/2 S. Okay, now I just need, so I know that this is 90 degrees also. So there's nothing else that this angle can be other than 30. And, well, this is a bisector. It bisects the angle, so I know it's 30. I could also determine that it's 30 because this is 90 and this one is 60, and 30 is the only other thing it can be. So now let's see what we can figure out. So the only number I have is on the length of the sides is 18. So I know I'm going to need that. So this is the long leg, and the long leg is equal to the short leg times the square root of 3. So my short leg is 1/2 s, and then I'm going to multiply it by the square root of 3, because in my theorem up here, the long leg is equal to the short leg times the square root of 3. So here's my short leg. So let's see what I have. So 18 is equal to 1 times s is just s, over 2. S times square root of 3 is s square root of 3. I'll put this over 1. So now what? So I've got to untangle s, right? So I've got a couple of ways I can do this. I can multiply by the reciprocal of square root of 3 over 2, or I can break it down into smaller steps. I think this time I'm going to break it down into smaller steps. So I need to get 2 out from the bottom, so I'm going to multiply it times 2. These cancel. What I do to one side, I have to do to the other. So 2 times 18 gives me what? So that gives me 36 is equal to s square root of 3. So now I'm going to divide both sides by square root of 3. And I need to look at how they want my answer. What is the length of each side of the pendant to the nearest 1/10 of a millimeter? So at this point, I can just divide in my calculator 36 divided by the square root of 3. And that's going to give me, so s is equal to 20.784. And there's some more numbers, but I don't really need them. So it wants to know the nearest 1/10 of a millimeter. So each side is 20.8 millimeters. And that's it.